Hi students, I want to go ahead and focus on calculating percent yield for this lesson. And so I've already got a problem set out for us here. And if you read that, it says that we have a balanced equation. So for the balanced equation below, what is the percent yield if 72.1 grams of CaCO3 produces 26.4 grams of CO2? Recall that our percent yield equation is going to be the following. I'm going to go ahead and write it up top here. So the percent yield, I'm just going to write that as a percent y, is equal to the actual divided by the expected times 100. And so that's the equation we're going to use, and we're going to kind of use that information here using all this information. Okay, so what we want to do first is we want to go ahead and draw our lines, and so here we go. Here's a line. Every time we see an arrow, we bring it down, plus sign, we do the same thing. And then we're going to create some rows here just so that we can begin to do our sections here. And so remember that the first line here is going to be the section for grams. MM is for molar mass, and then moles here at the very end. And so we're just going to plug in the information that they give us. And so when we do that, let me just erase some of this stuff so we have a clear area at the bottom to write on. And so at the very bottom, what we've got here is we're just going to transfer information. So let's kind of identify some of the important pieces in this section that they give us. They want us to find the percent yield, so we don't know what that is, but they do give us 72.1 grams of CaCO3 and 26.4 grams of CO2. So what we want to do is go ahead and enter this information inside the table that we've kind of generated here. So 72.1 grams of CaCO3, so I'm going to write 72.1 grams. And they want us to go ahead and use the information 26.4 grams of CO2. So that is actually going to wind up being the actual amount. And so we're going to put that as an actual amount equals to 26.4 grams. Now keep in mind that this is not the same amount or value that we're looking for when it comes to the expected, because that's what we're trying to find. The amount that they give us here is what they actually got when they ran the equation, or when they ran the reaction. They got 26.4 grams when they started with 72.1 grams of CaCO3. Okay, so what we need to find is the expected value. And the only way we're going to be able to find that is if we use the amount that they give us for the CaCO3, because that's the amount of the reactant. So we want to go ahead and figure out the molar mass and then figure out the moles. And we need to figure out some values here. And I'm just going to label them as X. And then we need to figure out the molar mass of Y. Okay. And so what we're going to wind up doing is we're going to use these numbers, X and Y, to figure out the E, or the expected value, or the expected number of grams from this particular problem. And so the molar mass here is going to be, molar mass for CaCO3 is going to be 100.1 grams per mole. And we need to do the same kind of calculation for the molar mass of the carbon dioxide. And so we'll just take care of that now. In other words, I'm looking for Y here. And so if I do that, essentially the mass of oxygen is 15.999, and there's two of those. And we go ahead and add the mass of 12.01 to it. Gives us a total molar mass of 44.01 grams per mole of the carbon dioxide. So all I need to do now is go ahead and take my 72.1 and I'm going to divide it by 100.1 over here on the left-hand side of the equation. And the reason I do that is because I want to figure out how many moles 72.1 grams really is. And once I get that information, I can then find the number of moles of the carbon dioxide, okay, using a mole ratio. And so the number of moles here for calcium carbonate is going to be 0.720 moles. And since the mole ratio here is 1 all the way across, 1, 1, and 1, I know that the number of moles for carbon dioxide is 0.720 moles as well. And so we're almost there. Now I'm going to take my value for X, which is the number of moles for carbon dioxide, and I'm going to take the values for my Y, which is the molar mass, so this number here, and I'm going to multiply it by the 44.01, and that is going to give me the E value here. And so if I multiply these two numbers here, what I wind up getting is 31 33.69 grams. So now I have an E value, and I already had an A value, so all I need to do now is plug into the equation, which I have up top. I'm just going to rewrite it down here at the bottom. So my percent yield is going to be equal to my A value, which is 26.4 grams. I'm going to divide it by my E value, which is my expected, or 31.69, and I'm going to take this value, multiply it by 100, and that will give me the percentage that I want. And that number comes out to, or that percentage comes out to 83.3% yield. And this is my answer for this particular problem. In the next video, we're going to be using a slightly different information. We're going to be using a starting amount for a reactant and perhaps the percent yield. And we're going to have to calculate how much of a particular product is going to be produced. And that's what's coming up in the next video. So for now, go ahead and subscribe us and check us out next time.